Good afternoon to Sir Judges and fellow participants. We are Group 4 of IDP and main title as others is a health monitoring system specifically for fall detection. Studies by World Health Organization suggested that approximately 30% of the individuals whom are the age of 65 and are likely to fall. This percentage is up to 50% for ages beyond 80. Risk of falling includes potential brain damage, losing confidence in oneself, in activity of daily living, as well as other health implications. Therefore, the problem is consumer-driven and there's interest from the market. Our study suggested that majority would prefer a wearable device which is functional and non-invasive. Non-invasive refers to minimized device size for reduced disruption in activity of daily living. So there exists a market gap for monitoring system, whether assisted or not, by human services. The targeted audience is primarily elderly over the age of 60 years old. The proposed solution is a watch which reduces the reliance on human workforce and has reasonable ease of use. At times of the pandemic, there may be shortages of medical helpers at home, so you can't always stay with your loved ones whom have aged. So having a device monitoring their health status is an assurance. Here shows a wearable IoT remote monitoring watch we proposed. It is bespoke, made for elderly, and has lightweight design meant for everyday use. The design considers for IEEE standards and has built-in additional features for additional ADL monitoring. So the safety code includes EEET4002, which is a medical device concerns the real-time, plug-and-play, and efficient data transfer. So real-time impacts in our watch design is basically instantaneous data transfer, so like split seconds. Plug-and-play impacts the user experience where automatic connection is done between the watch and the designated mobile device. Then with a medical device, the IEC 30165 framework is for IoT, which there should be efficient time communication and computation. For ISO 13485, it impacts our design as this code is meant for organizations whom supplies for device associated with medical services. Then ISO 14971 is a procedure to identify the risks associated with the medical device. So it impacts our watch design to reduce risk on the user. So this actually is the primary reason for the abandoned idea of external batteries due to mismatched specifications and risk of injuring the user with the external battery. So moving on, I ask my group partner to elaborate on the watch technical perspective.
Okay, thank you, Edison. So now I'm going to talk about the primary and extra function of our final product. So first, our product able to do the heart rate monitoring for the user. Other than that, our product also can do the body acceleration and radiation detection. And by using the body acceleration, we are able to do fall detection of the user. And if anything happen, we also can send a emergency message to contact the emergency contact person of the user through the Telegram notification. I will explain more about this in the methodologies. So other than that, for the extra additional features, our watch able to keep track of the body temperature of the user. Other than that, our watch also can able to do the activity recognition, which include resting, walking, and running. So for the methodology of our final product, first for the heart rate detection, as you can see here, the graph here. So basically when we take the reading and plot out our reading of our heart rate sensor, this will be the graph. So what you need to know is the peak value here will be our heart heartbeat for the user. So what we do here is basically for 10-second interval, we calculate how many heartbeat detected, then time by 6, we can able to get the BPM of the user. For the next one, for the fall detection, as I mentioned earlier, the M56C have the built-in accelerometer and also the angular velocity sensor. But it will take X, Y, and Z axis. So what we do here is we take the magnitude for both the acceleration and angular velocity. So when the high acceleration is detected from the user, then it's a potential fall detected. And then after potential fall detected, we will do 10-second counter and see is there any movement of the user based on their angular velocity. If there is not, then meaning the person is fall. But if yes, it's meaning that maybe the user is running or do something else. Yeah, it won't trigger our system to detect the fall. So next one, for the status recognition, we can detect stationary movement and also the moving movement, which we have walking and running. So how we differentiate the stationary movement and walking movement is by using BPM. Because when the user is moving, of course his BPM will be higher. So when the BPM is higher, then it will be walking. If not, then it's stationary. And how we differentiate the speed of the user, if it's walking or running, is based on the step counter in 10 seconds. If more than 20 steps, then the person is running. If less than, then is walking. So next one, for the temperature sensing, is basically we just install a temperature sensor on our watch externally, and we do conversion, take temperature reading. For the step counter, by using the accelerometer, we are able to calculate the step count of the user. And then last but not least is the emergency alert. So basically, when the user press the big button here for 3 seconds, then an emergency system will be triggered, which a Telegram emergency message will send to the emergency contact person through Telegram. And also the beep sound will be triggered, so it will alert the nearby person to help our user. And now for the flowchart of our final product. So first the program start, and then declare all the variable that we need, and then after that our watch will connect to the IoT cloud. And then after that we will read all the sensor reading, and then convert to the reading that we want. And then our system is actually not a parallel processing, but it can consider as, because once we run the code for one time, we can get all the reading that we want. So after do the processing, first we see is the emergency button pressed or not. If yes, then yeah, we notify the emergency contact person through Telegram and upload the data in IoT cloud. If not, jump to the next one, which is there any sudden acceleration? If yes, maybe, so the potential for detected. So is there any movement in 10 seconds? If no, meaning the person is fall. Yeah, do the same thing. Emergency message, I update in IoT cloud. If no, then we see what is the step count of the person. And depending on the step count and BPM, we actually can do the activity recognition, which is if more than is lesser than 100 BPM, meaning it's resting. If it's more than 100 BPM, is the step more than 20 in 10 seconds? If no, it's walking. If yes, it is jogging. And then we'll update the system in the IoT cloud again. And then for the demonstration, so as you can see, we actually put the heart rate sensor here, which will not disturb the people using his hand, and then it's connected to our watch. So yeah, every 10 seconds it can calculate the BPM and then update on our IoT cloud.
Okay, abnormal.
And then next one, when abnormal heart rate detected, which we will remove it. So abnormal heart rate will be detected, and then yeah, the beep sound will be triggered. Ask the person to nearby person to help, and also an emergency message will be sent through Telegram, as you can see here. Yes, abnormal heart rate detected, and also will be updated in our IoT cloud. Next one, for the fall detection.
Start.
When the user is fall, then potential fall motion will be detected, and then within 10 seconds, if the user don't have any motion, meaning it's fall. So yeah, you can see the beep sound will be triggered. Yes, beep sound will be triggered, and also the message will be sent through Telegram. Yes, fall detected. But if it fall down and have the continuous movement, then yeah, it's not, the fall will be one detected, and also the emergency message will not be triggered.
Okay.
And then for emergency button, if you fall for 3 seconds, yeah, then a watch will beep and then send a Telegram emergency message. Yes, emergency message detected.
Start. Okay.
Okay, so for the next one, for the step counter and temperature reading will be displayed on the watch, but at the same time, it will also be updated on our IoT cloud. This will be the patch of our IoT cloud, which can monitor the BPM, step counter, and the temperature of the user. And BPM will be plotted to easier for us to keep track. Last but not least, for the status recognition, if the status of the user will be changed, then yeah, it will be updated here with together with the time and date for us to do the tracking. And then for the limitation, M56C have the limited upload speed, which cause around 1.5 second delay whenever we do the IoT cloud uploading. And then for the precision, all the wire or all the sensor we use is actually linear circuit, which will be affected by electromagnetic. And at the same time, our wire is quite lost because we don't do soldering, because after everything done, we need to give the watch back. So yeah, it will affect the accuracy of the sensor also. And then the watch have limited lifespan. So after we install all the things, around 5 seconds, around more, lesser than 5 hours, our watch will be dead. And then for watch performance, we actually lower the CPU performance of the watch to improve our battery lifespan. And then for the output, like I mentioned earlier, it will be 1.5-second delay whenever we update. So we will actually do a timer for, we only update the clouding for after every 10 seconds. And then like we mentioned earlier, we add quite a lot of extra features which can help us to have a better understanding of the health of the user, but at the same time it will cost us more power losses as well. That's all from me.
So moving on, the watch design goes through a closed loop of product refinement cycle. So firstly, upon discovering the problem, the group came up with a design, and the design is a goal specific. So upon finding the goals and is identified, we develop the device towards the goal. Series of validation and verification will be done before testing. A revised prototype will be done based on the testing feedbacks, then re-evaluated the watch performance before determining if the device suffice and fulfill the problem stated. The whole process then restarts, and the problems is then justified if it's fitting the watch. Current stages is to revise the existing code, upgrade and use M5 stack core for more possibilities with the functions and therefore more potentials in the future, extend and discover the possibilities with the power management for prolonged usage and therefore a better user experience. Lastly, a plan to develop the tracking system, which is primarily using geolocation or an external GPS module to track the user location at all times. So in this business model, we have based our watch design on our research on modern needs in our society, and believe there exists a need for health monitoring device. Our design has simplicity and ease of use. The contrast traits includes low budget and therefore cost-effective device, simplicity, non-invasive, and the main draw would be affordability and ease of use for a reasonable number of functions. So with affordability and ease of use, you'd expect us to see, as seen in this graph. Device as mentioned by Sia has 3 buttons, and in our watch design, we reduce the user input and have parallel processing for sensing. So user inputs in most scenarios are not required. Assuming the device is well revised, then the graph shall follow the steps below. The date is just for a reference. We expect a rollout of the prototype to local hospitals, followed by a release to hospitals and regional market regions. The forecasted timeline is shown, as I mentioned in the strategy of growth in previous slide. You can have a insight of our planning. So initially, the first year would be first prototype testing, data hunt based on our R&D, and revise the prototype again. Then upon reaching the second year, there will be a rollout, deliver to local hospital and gather feedbacks. So in summary, the watch design is capable of closing the loop while delivering satisfactory experience and medical care. Use of IoT monitoring at times like the pandemic minimizes the reliance on human workforce for caring. With our device, non-invasive is a direct approach to better monitor elderly for remote locations and have quickest possible notifying to the admin. These approaches minimizes the likelihood of falling and therefore reduce the impacts and potential injuries from fall. This is a group photo of our team members, and we welcome any questions that you guys have in mind.